Hi, fifth grade. Welcome to your first video lecture. Today's lecture is about motion and work. If you have not gone onto the Google Doc and pulled up the slides so you can look at them while I talk about them, please do so now. Pause the video, whatever. You just go on to Thursday, and where it says lecture slides, just click that little link that says here, and it'll open up the Google presentation for you. If there are any problems with tech, please email me. Anyway, I have really bad allergies right now, so I'm sorry if I have to sneeze or something during this. So, if you have the slides pulled up, please be sure to be copying them down. If you'd like to print them out and you have a printer and you just want to take extra notes based on what I say, go for it. Just make sure that you do take notes on the things I'm saying and not just what's on the screen, as always. Okay, so your warm-up is how do we measure a car's speed? So think about it, jot down a little answer, pause the video because I'm about to tell you. Okay, so if you ever paid attention to like when your parents are driving the car, you'll see that it says like they're going 45 miles per hour, or it might just say 45. Um, that's how we measure a car speed. What we do is we take the amount of miles it would take, I mean, the amount of miles we can go in 1 hour at that speed. So what 45 miles per hour is saying if we drove for 1 full hour at this constant speed, we would travel 45 miles in that 1 hour. If you ever heard the phrase a mile a minute, that would really be like going 60 miles per hour because you go 1 mile every single minute because there's 60 minutes in an hour. You know, we'll get more into that in a bit. So, your first slide is your title slide. It's motion and work. These are pages 78 to 81 in your textbook. It's the first two sections of chapter 7. We skipped and went to simple machines first, but it's fine. So, excuse me. The first thing we need to talk about is how do we describe motion? So, there's lots of different ways to describe motion, so I came up with an example first. In finding the amount of distance traveled, say we're in a car and we went from your house to the school, you want to know the amount of distance there is. What you would do is you would use a reference point and then a specific position. This example would be the end point of the school parking lot. So the reference point would be your driveway and the end point would be our school parking lot. Motion, in describing this distance, we would, if there was some way to sit there and measure without having to take out our ruler, fortunately GPS does that for us already, we would know from my house it's approximately 10 miles, I think. Yeah, about 10 miles. So my reference point was my driveway, and all the way to the school parking lot is about 10 miles. Remember, to factor in, you can't just drive straight there. You have to take roads. It would probably be a shorter distance if I could just hop from my driveway all the way to the parking lot, make my commute a lot easier, but whatever. So the key to get from this is that motion is described by making a comparison. In this example, the comparison was from one point to another. In our speed example, in our car, we are comparing distance to time. Okay? So motion is all about making comparisons. That's your big idea for the day. So the first thing about motion we're going to talk about is speed. Speed is one of your vocab words. It's defined as the amount of distance traveled in a given amount of time. When we're comparing distance to time, you're seeing how fast an object moves from one point to another. An example, the car is moving at 35 miles an hour. In 1 hour, if that car traveled at this constant speed, it would be 35. Same thing as in our more of example 45 miles an hour or whatever it was. 45 miles in that space of 1 hour. It's not always miles per hour. We know in Europe they use metric, so they use kilometers per hour for their cars, but you could be measuring the speed at which a football player runs across the field, and it would be like yards per second or something. It's really whatever your distance is compared to the amount of time that you want to know. So if you look at the next slide, speed continued. Calculating speed requires division, which we know how to divide. You divide distance by time. So your distance is on the top if you're looking at a fraction, or on the left if you're looking at it as like a 6 divided by 3. So the example of 120 miles divided by 2 hours is equal to 60 miles per hour. mph is how we abbreviate that. So remember, when you do division, you read left to right. So if I do it in the calculator, I'm using my phone, sorry, that's all I have. Open up calculator. So what we're going to do is we're going to do 120, type in 120, then you divide 60, 2 is 2 hours, equals 60 miles per hour. Yay! Alright. So, again, please copy down that formula. You do have to know how to use that one. There will be like a couple short little ones on your quiz. This is the only math you have to do though. Yay! Make sure you label your units correctly. I'll always give you units, like I would give you miles an hour in that info. So we're going to do some speed calculation practice. Yes, but the answer's on there for you to check your answers, but I want to see that you know how to do it. So, first problem, 80 yards compared to 20 seconds. So what you're going to do is, I closed my calculator, 80 divided by 20, idiot, equals, should be 4 yards per second. I had a typo on my slide, I'm sorry. So 80 yards divided by 20 seconds is equal to 4 yards per second. And how you write that is you can just write yards over sec, like SEC. Or if you don't know, you can just always write the full words yards over seconds. This is just like when we did density and we were doing like grams per milliliter. When you divide units that aren't the same, you just write them as like a little fraction. So take a second, pause the video, see if you can figure out 2 and 3. Pause it. Don't just listen to me say it. I'm watching you. Okay, I'm not. I can't see you, but alright. Pause the video, and I'm going to talk about the answers now. So, next one, 3,000 meters per 100 minutes. That's simple. All we got to do is 3,000 divided by 100. Should have that. Equals 30. You can't really see it, but it equals 30. 30 meters per minute. Simple, right? Last one is 40 inches per 1 hour. I'm not going to do this in the calculator because you should know what 40 divided by 1 is. It is 40, because if you divide anything by 1, it's just itself. So 40 divided by 1 is 40. Sorry. 40 divided by 1 is 40. So it's 40 inches per hour. I'm going to guess we were measuring the rate a snail moves or something, because they're slow. Alright. good with speed calculation. That's the only calculation you have to know how to do. There's another one later that I'll just talk about. Okay, velocity. Velocity is defined as the measure of an object's speed and direction. So each of these things that we're going to talk about ties in the ones before it. So you have to know something's speed to be able to figure out velocity. You also have to know its direction. So velocity does rely on direction. It's easier to explain this with an example. So if two buses are both moving at 65 miles an hour, but one is heading north and one's heading south, they have different velocities because it relies on the direction. So they could be going the same speed as much as you want, but unless they're heading the same exact direction, their velocities are going to be different. Okay? Velocity relies on direction. It's a comparison of speed to direction. So if I wanted to say our snail from the last one, his velocity is comparing his speed, which was 40 inches per hour, but his direction is northeast, that's his velocity. Okay? You don't have to calculate velocity. Acceleration. Acceleration is a change in velocity over time. So you've probably heard the word acceleration before, and when you've heard of it, you've always thought of it like speeding up as acceleration and slowing down as deceleration. But it's not just a change in speed. It's also a change in direction because it involves velocity. So it's really the rate at which your velocity changes. So let's say we're driving in our car and we get up to whatever speed we want to go, but then we have to turn left. Our acceleration is now changed because our velocity changed. Alright, it can be as simple as your speed changing, but it's not just that. Remember, acceleration also has to deal with direction you're going. Okay? So, that was the whole first section of chapter 7, the first 2 pages. We're going to go into the next 2 pages now, which is all about force and work. We talked a little bit about that stuff when we did our simple machines, but we're going to get more in depth with it now. I'm sorry for my voice, I just woke up. And I haven't had my coffee, and you know Miss B loves her coffee. So, force. Force is basically the amount of effort it takes to move something or do something, like in our pulley example of pulling up the bag of the books. You needed to exert some force to pull that string to lift the pulley, or with the cars going up the little ramp, you had to exert force to pull them. Okay? So, Isaac Newton, the guy that discovered gravity, you've heard of him before. He has a bunch of laws that he theorized and made up, all about gravity and all that. So his second law states that force is equal to an object's mass multiplied by its rate of acceleration. So force equals mass times acceleration. Force equals F equals m times a. Simple. It's multiplication. Yay, no division to worry about. Alright, think about that. So if I were going to push a box of books across the table, its mass, let's say, is 2 kilograms. And the acceleration would be, its velocity, and it's over the time it took to do that. So let's say it took me 3 seconds to push that box of books across the table. So the force would be the mass, the 2 kilograms, times the acceleration, say it was, I don't know an example of the acceleration math, I'm sorry. But you'll see more in a second. Okay, so we're switching to the next slide. The force calculations, I fibbed earlier, sorry, you do need to know one more little calculation, but this one's really simple. And you don't have to worry about units as much because the unit for force is called a Newton. We named it after Newton because he's special. So when you do this, all you do is you take what's given, the mass and the acceleration. In this example, I used gravity as our acceleration, so imagine that I'm dropping 2 objects from a height, and the acceleration is the pull of gravity. Okay? So my mass is 30 grams times the 9.8 meters per second squared. That's how you measure gravity. Gravity is a constant on Earth, so that's nice. So if we do 30 times 9.8, ta-da, and hit equals, you're going to get 294. And how to label this, all you do is write an uppercase N. You don't have to worry about dealing with the grams or the meters or the seconds. It's nice. All you do is write an uppercase N for newtons, because that's how you measure force. So go ahead, pause the video, try to do number 2 by yourself. Yay. Again, I apologize for my sniffly nose. This pollen is terrible. Okay, so, I hope you did it by now. 180 times 9.8. Should type that into a calculator. 1,764 newtons. As simple as that. Just make sure you type it in correctly. So, force calculations are pretty easy. I'll give you the information you need for them all the time. Again, it's mass times the acceleration, so mass times like how much what's it called? The change in velocity over time. So our velocity changed by 9.8 meters per second squared. So we pushed our box off the edge. It falls at 9.8 meters per second squared, and the box weighed 2 kilograms. So whatever 9.8 times 2 is, it would be the force of our falling box. So the next thing that comes is called work, and work is defined as a result of force applied to an object that causes it to move. So basically, when I push the box, the effort I'm putting in, or the force that I'm doing, is called work. Work only occurs if the object moves in the same direction that the force applies. So I am doing work when I'm pushing that box across the table. But when I push it off the table and it starts falling, I'm no longer doing work because it's a different direction of the force that I applied. So the example on your slide is that lifting a backpack off the floor. The force you are exerting is lifting up, and the backpack is going up. But if you were to just walk across the room with it, that's not work, because what you're doing is you are exerting the force to keep it lifted in the air, but now you're just walking forward. You're not exerting force in a forward direction. Your force is still going up, so that's not work. I hope that makes sense. It's talked about in your book. All this stuff comes from your book, so read those pages, highly suggest, if you're confused. So energy, you've heard about energy before. Energy is technically defined as the ability to do work. So it's used to apply the force to something. Like in me pushing the box of books, the energy, like how much energy I need to push it. So it's used to apply force to something, and when the force is applied to the object moving in the same direction, we get work. It's another math problem, but you don't need to know how to calculate this one. This one's weird. So just know that work is measured in a unit we call joules. Fun word, joules, but it's not like sparkly jewels. It's Joules because it's named after somebody, I think. Um, so the example is work equals force times distance. So if we have a force of 7 newtons and we move it 4 feet, whatever thing we're moving, box of books, it takes 28 joules of energy to do so. Yeah, it's really simple, but it gets really messy, so I'm not going to make you guys calculate that. Okay. This is the last slide in the presentation. At this point, all you need to know how to calculate, remember, were force and speed. The two really simple ones. You don't have to get into acceleration. You don't have to get into velocity or work or anything, but I just wanted to explain it to you all for when you will have to eventually do this in the future. So this week, today's Thursday, so tomorrow, Friday, you guys will have a review for an online quiz that you will take on Monday. Because we ran through this stuff really fast, I will allow you to use your notes on Monday. It'll be like mainly multiple choice, a couple fill-ins. That's it. It'll be online, so it'll be like a Google form that I'll put a link to on your calendar. You just click it and you fill in the answers, you hit submit, and you're done. So if I allow you to use notes, use your notes, kiddos. You will need a calculator, but like I used my phone calculator, it doesn't need to be fancy. You can even use one on a computer if that's all you have. Okay. So please email me if there are any questions about this info. I forgot to apologize for my webcam quality. It's not great. But hey, we're here, we're learning, we're getting through. So please make sure you watch this video, take notes on it, watch as many times as you need to understand. Email me with questions, alright? Bye. Please wash your hands.